Yes. Yeah, that's a good question. How it's recording but not recording me.
Yeah.
It's not recording me. It's recording what happens on the board.
Oh, that's.
So it doesn't see you and it doesn't see me, but it can hear us. So here's the thing, guys. If you got in trouble, your parents could hear it. Right. Okay. But we don't want to focus on negative. We want to focus on positive. So if you did something, you could answer questions, your parents could hear that too, which is positive. So this is where the last recording left off when you guys did the coming into class today. We talked about finding multiples, right? That would be these over here. And we talked about finding factors over here. And last night we focused on finding the least common multiple in the homework. So we call that's right, the LCM. And so when we look over here on this side, the common multiples, we ready, girls? The common multiples are 24 and 48 because they're in both lists. But the least common multiple, the smallest of them, is 24. In your homework today, one of the things you have to do is find the greatest common factor. It's kind of like opposite thinking. So to find the greatest common factor, you would list all the factors of 8. So here are the factors of 8. Okay. And then list all of the factors of 12. And then you're asked to find the greatest common factor of 8 and 12. So there's lots of common ones. One's common to both. What's another one, Peter, that's common to both?
It's common to both. 2.
2. Echo, what's another one that's common to both? What number shows up in both lists?
4.
Good. 4, right? And then, Kaden, are there any more?
And then it would be.
Is there another common factor?
I ended it right there.
I ended it right there. So of the 3 numbers that are common to both, what's the biggest, Kaden?
4.
4. So we call that the greatest common factor. Raise your hand if that makes sense. Okay. So practice today. Let's practice. If I ask you, which you're going to be asked to do in your homework, one of the things is to find the greatest common factor. And we call it the GCF. A lot of times you'll hear me say that. Greatest common factor of 2 numbers. How about of 16 and 40? My first step is to list all of the factors of 16. So you want to start that for me, Allie? 1 times?
1 times 8. 1 times 16.
Okay.
2 times 8.
2 times 8.
4 times 4.
4 times 4. Okay, Kay, how about the 2 factors of 40?
1 times 40.
1 times 40. How about 2? Does 2 go into 40?
Yeah, 2 times 20.
Does 3 go into 40?
No.
No. Does 4 go into 40?
Yes, 4. No, wait, 4 times 10.
Yep. Does 5 go into 40?
5 times 8.
5 times 8? 6? 7? So those are all the factors of 16 and the factors of 40. What's the biggest common factor? Right in?
Biggest common factor?
Mm-hmm.
8.
8, right? Because 1's in both, but that's pretty small. 2's in both. 4 is in both. And 8 is in both. And that's it. So the greatest common factor of 16 and 40 is 8. Raise your hand if that makes sense. Okay. So what I need you guys to do is open up your book, and we're going to look at page 34, real quick. Yeah, the applications page, it's black on the top. You see problems 1 through 8? This is like problems 1 through 8 on page 34. Does that make sense? Okay, so turn back a page. There's a more interesting problem that we're going to finish class with. It's the bagging snacks problem. Okay, so I want you to look at that problem. I'm going to pause this for a minute. So finish up reading the bagging snacks problem.
Yeah, I'm done.
Okay, so when you read a problem like that, let's have everybody stop, look, and listen. That means you want to be looking at me, right? Turn your chairs and stop writing for a minute. When you read a problem like that, it's about Jen and her friends and they go hiking. So Jen, tell me something that's a key, like, what's the problem asking you to figure out?
How can you have an even amount of an apple and an even amount of trail mix as like a snack pack?
Okay, good. So like, let's suppose you have some apples, right? I have little apples here. And then you have little trail mix bags, right? Well, just those little tiny trail mix bags. It's like stuff in there, right?
Yeah.
And so, you know, if you had a bunch of apples, you know, we had a bunch of apples, you want to be able to divide them evenly. How many apples did they have? 24. And then how many trail mix bags did they have? 36. So, you know, that's a bunch, right? And I'm not going to get them all here, but you want to take all of those things and break them into a bag. So each bag has the same amount of apples as every other bag. And each bag has the same amount of trail mix packets as every other bag. Is this a multiples problem or a factors problem?
Factors and multiples.
Okay, so let's talk about key information, and I'm going to ask you the question again. Tell me something in that problem, Haley, that was useful. Like, what do we need to know?
Well, it says the amount of trail mix bags and apples.
And how many apples do you have?
24.
That's important information, right? 24 apples, and how much trail mix?
36.
36 bags of mix, right? Okay, and then we're going to make like baggies, right? And in our packets, we're going to have a bunch of apples. So they're like, you know, we're trying to figure out how many apples and how many bags of trail mix are in there. That's the problem, right? Okay, so the question is it a multiple problem or a factor problem? Well, if it's a multiple problem,
And you
wait a minute, let's talk about that. What's wrong with that?
there would be too much.
The first multiple after 24 is what? 48, and we don't even have 48 apples, right?
Yes.
So it can't be a multiple problem like yesterday.
It has to be smaller than 36 and 24.
Yes. It has to be smaller than the numbers, and the numbers that are smaller are factors. Okay? Does that make sense? Good job. Kate. And Kate. Hannah. So, yeah, we are going to answer it. So, I want to just put it into a chart. We're not going to probably answer all the parts of this today, but enough to get an idea of what's going on in the problem. So, like, we have the bags, right? Or the packs, I think is what it says in the reading. How many packs? Maybe like backpacks. And each pack has to have some apples. And each pack has to have some trail mix. And so, if we're going to do that, we have to figure out the factors because we want to be doing division. So, can you, Kaden, do the factors for 24 for me?
1, 2,
So 1 times 24, 2 times
12,
3 times?
3 times 6. No, 8. And then 6 times 4.
Okay, good. And then, Catherine, how about the factors of 36? Uh-huh.
2 times 8.
Right.
3 times 12.
Good. Do that shortcut. 4 goes into 12 how many times? What's 3 times 3?
9.
So 4 times 9. How about 5? Does it go in? What about 6? 6 times 6. Okay. So if we look at the factors, then we can figure out what factors will work. Like, can I make... So you think I could have 6 packs? Somebody said 6? Did you? Okay, well, let's try 6. If I had 6 packs, how many apples would I have? Because I have to divide the 24 apples evenly. Yeah, Allie.
6 apples?
No, because if I had 6 packs and I only have 24 apples, right? If I have 6 packs,
I would have 6 packs, then it would be 4 apples.
I'd have 4 apples, right? And then Antonio, how many bags of mix would I have?
Inside of that?
Yeah, inside the big pack. So I'm going to take my 36, 6, right? So the common factor is 6, and I would have 6 little packets of trail mix in each backpack. So I could do that. My question is, could I do like groups of 8? Could I have groups of 8 here? Why not, Peter? What?
Because 3 and 8 wouldn't really work. Well,
I could break 24 into 8 equal groups.
but I can't with 36.
I can't with 36. So I'm really only interested in the common factors. So what would help me is if I circled the common factors first. Like 2 is a common factor. So I could do 2 backpacks, and in each backpack, how many apples would I have? 12, right. And Echo, how many bags of trail mix would I have?
Wait, sorry.
So I have 18, right? Because that's the factor pair. So the next common factor is 3, right? So if I had 3 backpacks, somebody new, Isabella, how many apples would I have? 8, because I would be dividing 24 into 3 parts, and so I would get 8. And then how many bags of trail mix would I have? 12. Okay. What if I had 4 backpacks? Is that going to work? Yeah. To Aiden.
Yes, yes, it will work. So, the apples would have 6 in them, and the trail mix would have 9.
Right, 4 and 9. Okay. Could I do 6? We did 6 up here, right? Can I do anything else? There's another one. What's the other one? That's common to both. Allie sees it. What is it? Okay, 1 wouldn't be dividing it up, though. It's true. What's another one, Catherine? 12. 12 is common to both, right? So if I had 12 backpacks, how many apples, Catherine, would I have in there? 2. And then how many little baggies of trail mix? 3. Okay? We don't have time for the whole problem, but that's the basic idea of your using factors to solve a big problem. So here's the thing, I'm going to record this, but because I have to go to a doctor appointment for my daughter at 4, I probably won't be able to post it till tomorrow.
Okay.
But it will be a good review problem, and then you guys can go kind of, we can listen to it tomorrow. Yeah, Thursday. Okay?
Hey, what are we
Bye.
doing for this homework?